Alrighty. How are we all doing?
Good.
Fantastic. Awesome. So today I'm teaching y'all about differentiating qualitative observations from quantitative observations and the importance of it in the scientific method. So before we actually talk about the different kinds of observations, let's talk about the scientific method and just review that real quick. So every time, whatever science class you're in, whether you're in physics, chemistry, biology, y'all be taking biology next year as freshmen, so this is going to be a big deal, and they're going to try and drive this into your head for the next 4 years. We always start with our observation and question, and then after that we do a little bit of research on the topic. So when you have labs in college, they make you do these really, really long assignments talking about researching your topic and figuring out how you're going to test things. Then you're going to create your hypothesis, which is a statement. There's two kinds of hypothesis. You have your alternate hypothesis and your null hypothesis. Your null pretty much says, I do not expect anything to happen. Your alternative hypothesis is something along the lines, if I was testing like light or something, I'd be like, this color of light is going to have this effect on my procedure or on my control. After that, we would test that with an experiment that we'd come up with. We'd analyze our data using our different types of observations, and then we report our conclusions. Now, the most important part of this is a continuous process and therefore never stops. So you keep going around in circles forever and ever, and that's why this is so complicated. The second thing, we never prove anything when we're talking about the scientific method. We just rule things out. So let's first talk about qualitative observations. These are not numerical, so these are things like color, smell, shape, texture, etc. Can one of y'all give me an example of a qualitative observation? Alea, you look really keen to answer this question.
Say, like I said, an apple is red. That is a qualitative
That
observation.
is a very good qualitative observation. Can you give me another one?
The apple smells like an apple.
That's not as great, but I'll take it. So the other kinds of observations we have are quantitative observations. These involve numerical measurements. So when we're talking about length, mass, density, the amount of substance in a material, and these are measured in SI units. We're going to talk about SI units next. SI units are the standard for how the scientific community measures things. Most of the time these are in the metric system, but not always. Like temperature is kind of an exception. And then there's some other ones that are kind of just like made up. Like newtons is the SI unit for force, and that's kilograms per meter or something like that. I don't remember. I'd have to check that. So our SI units, the way these work, we have time, length, mass, electrical current, thermodynamic temperature, and amount of substance. We measure time in seconds, we measure length in meters, mass in kilograms. The reason we do mass in kilograms is mostly because of physicists that are measuring planets, and trying to measure everything in grams would be too much of a pain in the butt. Electrical current is measured in amperes. Most of these have really simple symbols, except when you're talking about current. Current is I, but then the symbol for ampere is an A. So when you take physics in high school, that's going to confuse the heck out of you, because it confuses the heck out of me. Temperature we measure in Kelvin. So do you guys know what Kelvin is? Yes, no, maybe? So Kelvin is Celsius minus 273 degrees or plus 273 degrees, depending on how where you're trying to get. So 0 Kelvin is the spot where nothing is able to move. So if you froze something at 0 Kelvin, all the little atoms are going to stop moving. And then the amount of substance, you'll learn this in chemistry, is a mole. Now, I have two little mnemonic devices to help you guys memorize the basic SI units and the units that go along with them. So I'm going to introduce you to my friend Tom. Tom likes miniature X. That smell. Get rid of the amount, substance. So time, length, mass, electrical current, temperature, and substance. Tom likes miniature eggs that smell. And then he has his friend. Yeah, I know. Not my best work, but it works. And then if we were going to go through and we were going to memorize all the base units, we have our friend Sam. So Sam stands for seconds. Sam makes kind announcements concerning monkeys. We're going to disregard the fact that there's a C in concerning. It sounds like a K, so it works well enough for what we're trying to do. We got it? Maybe?
Yep.
Alea, you really look like you want to try and recite it and tell me what all of them mean, and I'll even let you pick one.
Here, we'll go with the name.
Okay.
Tom likes miniature eggs that smell.
And then what does all that stand for?
Time, length, mass, electric current, thermodynamic, temperature, and amount of substance.
Fantastic. Thank you. I appreciate it. You can turn it off now.